So this is a problem with circular motion. Let's take it step by step. So we have a toy car on a circular track and it's accelerating. It's got a tangential acceleration of 5.6 meters per second squared. First it asks, when is the car's tangential acceleration equal to its centripetal acceleration? So what we want to do is we want to take the centripetal acceleration, which is v squared over r, and we want to set that equal to the tangential acceleration, which is 5.6 meters per second squared. Well, we know r is 1.3 meters, so that lets us solve for v. V is the square root of 5.6 times 1.3, which is 2.70 meters per second. Now, if I consider the linear motion of the car, I don't know delta S. I know it starts at rest, has a final speed of 2.7, and has an acceleration of 5.6, and an unknown time, so let's find delta S. I'll use this equation to find delta S. I get delta S is equal to 0.65 meters. Okay, now I want to know how many laps has this thing completed. So I guess it would be best to convert this into radians, right? So delta theta is delta S over the radius. So 0.65 over 1.3. So that's half a radian. And then if I convert that to revolutions, I multiply by 1 rev over 2 pi radians, then I get 0.080 revolutions. So the car has not gone very far. Right? Part B. So this is one where the car is about to slide off the track. So if I consider, okay, so let's consider this circular track. So this is going to be a side view of the car on this circular track. Okay, so at any given moment the car's on this track and it feels a normal force, gravity, there's a centrifugal force, and then what's holding it in place here is static friction that keeps it from sliding off the track. Since the car is just about to slide off the track, we can say that the force of static friction has its maximum possible value, right? This is a threshold problem. It's just about to slip. So that means we can use mu sub s times the normal force for the force of static friction. So let's see, the sum of all the y forces, if I use my traditional sign conventions, is that it's the normal force minus mg equals 0. And the sum of all radial forces is the centrifugal force minus the force of static friction. That's also equal to 0. Alright, so let's see, what can I do here? I can take this equation and I know the normal force is equal to mg. So that I can take that mg and I can plug it into the second equation, which is mv squared over r minus mu sub s mg equals 0. And there's only one unknown in this equation, and that's v, because m cancels out. So I have, if I solve this, I get v squared over r is equal to mu sub s times g, or v is equal to the square root of mu sub s times g times r, which works out to be 3.4 meters per second. Okay, so there's our final velocity for this part. At 3.4 meters per second, the car's just about to slide off the track. How much time has passed? How many seconds have elapsed? Again, this is a, motion with constant acceleration. So I don't know delta S. I know v naught is 0. This isn't one of those where the final velocity for part A is equal to the initial velocity for part B. We're really in part B. We're starting over. Okay, you don't link those two parts. And then acceleration is 5.6. And now we're trying to solve for the time, so I'll use the equation that doesn't have delta S in it. And I get a time of 0.61 seconds. So again, not a very long time. Finally, it asks, what is the car's angular speed the instant before it slides off the track? Well, the linear speed is 3.4 meters per second. The angular speed is just the linear speed divided by the radius, so that's just 2.6 radians per second. So that part was pretty easy.